Hey everybody, now we're going to begin the lecture for chapter 6, which is on conservation of momentum, and this is a process that's used to describe collisions. So here are your variables that we'll be looking at, and the set of formulas that you'll be looking at. So first, let's just go back to what we know. An example that we're going to look at is a collision between a baseball bat and between a baseball and a bat. And so what's happening here is, well, if you look at it, well, first of all, we know that the bat is going to exert a force on the ball because you can see here that this is the normal dimensions of the ball, and you see that the ball is deformed, and the only way that that's possible is if the bat exerts a force on the baseball. So but now, according to Newton's third law, forces always come in equal and opposite pairs, and this picture shows you here that the bat exerts a force on the baseball, but as you can see here that the bat itself gets deformed, so that the baseball exerts a force on the bat. So we're just going to start off by what we already know, in that here forces are being exerted, and we can apply Newton's second law, which says that the force acting on an object is equal to its mass times its acceleration. And so if we try to draw a picture for what's happening here, just a simplified version, you just let's say you take this is a wall, and then you throw a ball against the wall. The ball has a mass m. You throw it with towards the wall. The ball is going to be moving with the initial velocity v, and then the ball hits the wall, and the ball bounces back with some final velocity v final. So essentially, before and after here, the ball changes direction, so it accelerates. And so we can rewrite the acceleration in terms of another formula, or acceleration. Remember from a previous chapter, acceleration is defined as final velocity minus initial velocity over time. So from that, we can just write the Newton's second law in terms of force is equal to mass multiplied by final velocity minus initial velocity over time.